This video covers part of 6.5 Practice 2. It just covers the part related to functional groups. There is no lecture for functional groups. It was just embedded into this practice set. So what are functional groups? The reason we're looking at that is because functional groups are often thought of to be part of a larger molecule. And if we're working towards looking at the structures of larger molecules, and we need to get familiarity with the terminology of functional groups. So just reading the bullet, functional groups are specific groupings of atoms within molecules that have their own characteristic properties. So when we study a functional group, that group always functions the same way, even when it's part of a larger molecule. And when the chemical structure, this is second bullet, when the chemical structure for a functional group is presented, there is often either one bond left blank, or at the end of the blank bond, an R is put there, and an R essentially represents where that functional group attaches to the rest of the molecule. Okay, so we start with a question that in some ways looks familiar. The Lewis structure for the hydroxyl functional group, OH, is shown below. So you're never going to have to know names and what the structures are on the test. So every question on the test will give you the structure and will name the functional group, so just so you get exposure to it. But you don't have to know the names of the functional groups. So this OH right here, and in this drawing it's actually showing the valence electrons and it's showing the single bonds, but in the text portion of the problem it just says -OH. And so that's the radical group named hydroxyl, and the R is where this functional group attaches to the rest of the molecule. So the first question is, draw the 3D structure. Well, the oxygen looks like the central atom, and the oxygen has, let's switch pen colors here, the oxygen has 1, 2, 3, 4. It has 4 electron domains around it. Electron domains being regions of space around the central atom in which electrons reside. So the template I'm going to use to draw this is the oxygen here, and 12 o'clock, 4 o'clock, one bond coming out of the paper, and one bond going behind the paper. Okay, so now in going from the 2D representation on the left to the 3D drawing on the right, it's my choice which of these 4 drawn bonds I make the bond of the H and the bond of the R. And there's a convention, you don't have to use this convention, but there's a convention that if you just got 2 bonds, use the 12 o'clock and 4 o'clock because they're in the plane of the paper. So I'm going to put my H here, my R here, and then what I have to do is I have to erase the placeholder bonds at the coming out of the paper and the going into the paper. There's the one that was coming out of the paper, there's the one that's coming into the paper. And the reason I'm erasing those is because they aren't actual bonds. They're just these lone pairs, the 2 lone pairs. So at the one coming out of the paper, I'm going to place 2 dots, and at the one going into the paper, I'm going to place 2 dots. Okay, and that is now my 3D structure, 3D drawing of the hydroxyl group. Now this, quote, 3D structure isn't very 3D because we only had 2 bonds coming out of the central oxygen. We drew them at 12 o'clock and 4 o'clock. So this is a drawing that exists on a plane. This is a structure that exists on a plane. And from this word bank of 1, 2, 3, 4, 5, of this word bank of shape names, this is bent. Okay. Now it looks like I missed a question there in my own sequence of questions. So back on A, this question specifically was asked, how many electron domains does the central atom have? We had answered that in our count of 1, 2, 3, 4 electron domains. So I'll write 4 here, and I'll move to the next problem. Okay, this next problem here is not a functional group problem, so I'm going to skip it. It's not that this question wouldn't be a very small part of your test. It's not that it's not worth talking about, but I wanted this video to be about functional groups. So let's see what more we have on here. Here we are. Okay, the amino functional group, hyphen NH2, so what that's showing us is that the hyphen represents where this functional group attaches to the molecule that it's a part of. The functional group NH2 is shown to the right. So in showing it to the right, we're seeing a central nitrogen atom, we're seeing bonds, two NH bonds, and then we're seeing this bond that hasn't been left blank, but it's put an R there, and R is just representing where that functional group attaches to the rest of the molecule. So this is another one that's it's very common in biology. So this question states, in the space below, draw the Lewis structure for ethylamine. Ethylamine consists of C2H5 attached to the amino group. Okay, so on our actual test, questions like this are designed a little bit differently. I think I show you a big molecule and I have you find the functional group. But let's take this question for what it is. So we've got C2H5. We had done a lot in class on this, and so students would know, they would have a sense for the C2H5 being the two carbons bonded together and 5 hydrogens being bonded to the outside of the molecule. That's a bond right there. Okay, and we've talked a little bit about the need for stable octets. So this carbon on the left has 1, 2, 3, 4, 5, 6, 7, 8. So it's got a stable octet. And this carbon on the right, 1, 2, 3, 4, 5, 6, 7, 8. That's got a stable octet. But of course, this bond then attaches to something else. Well, what it attaches to is the amino group. So the amino group needs to be brought down here. And so I'm going to draw the N, the H, and the H. Okay, so this part right here, that was a mark from highlighting something else. That right there is the molecule ethylamine. And what I've been able to do as the student is show the amino group as part of a larger molecule. All right, there may be one more functional group question on here. So once again, I am giving you the name of the functional group, hydroxyl, writing it to you in paragraph form, if you will, and then I'm also giving you the structure. And on no part of the actual test you have to know the names of these. So this says, draw the Lewis structure for hexanol. Wow, that looks like a pretty big molecule. Hint, the 6 atoms are bonded to each other. So in class, we had done a lot with carbons and hydrogens. The carbons will form a backbone, so we will assume for this that they're all in a straight line. 3, 4, 5, 6. And then we've got 13 hydrogen, which surround those 6 carbon. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So most of the carbons on the left, the 1, 2, 3, 4, 5 coming in from the left, they already have their stable octets. And this carbon here, most on the right, needs one more bond to give it its stable octet. Where's that going to come from? That's going to come from the hydroxyl group. And so the student's demonstrating an ability to attach a functional group and show it to be part of a larger molecule. So then I'm going to put the oxygen here with the lone pair have the single bond and the H. So our hexanol molecule is this right here that I'm circling. All right, and that is hexanol. And just quickly, we've got just a short amount of time left in our trying to keep it 10 minutes. So just because this attaches to what we've been doing earlier, this says to label the delta plus and delta minus of the hydroxyl group. So the O, using my electronegativity chart. The O is delta minus, the H is delta plus, and the rest of this molecule here, this is all, I know this is probably getting messy at this point, my apologies. This is all essentially nonpolar. I'm writing fast, I'm over 10 minutes. And this is the polar part of the hexanol molecule. Thank you.